Problem 6. Follow these steps, which illustrate an alternative to straightforward division to obtain representation 8 in example 2, sections 67, 8. In section 73, problem A, write. This problem, in fact, give another way to compute the coefficient of this function. I mean the series division of power series. So first we write this is equal to the series given in right hand side here, where the coefficients in the power series on the right are to be determined by multiplying the two series in the equation, which means that we multiply these terms both sides. So on the right hand side can be cancelled. We get this 1. On the right hand side we need to compute the product of two series here and here, and then perform the multiplication to show that these expansion series, I mean that series expansion equal to 0, where modulus of g is less than pi here. Okay, let's check it. Since 1 over g squared times hyperbolic sine g is 1 over g cubed times 1 over 1 plus g squared over 3 factorial plus g to the power of 4 over 5 factorial, like this, keep going. By example 2, section 73, because hyperbolic sine g, we just see that the similar result here. Okay, do you remember here? Hyperbolic sine g can be explained by using this formula. So we just factored by g and the other terms. So in this case, we 1 plus g squared over 3 factorial times plus g to the 4 over 5 factorial, then which is hyperbolic sine g. So we use the series expansion for the hyperbolic sine g here, then we get this result. So we'll calculate this now. To do it, just let this equal to this series expansion. So we need to compute the coefficient di here. So we multiply 1 plus g squared over 3 factorial plus g first over 5 factorial, both sides, and we get this result. And just multiply term by term and arrange terms with the same power. Then we get this coefficient, and I mean that g0 plus d1g plus d2 plus 1 over 3 factorial gg d0 times g squared, like this here. Then we move 1 to the right hand side here. Then we get this equation here. We compare by comparing the coefficient both sides. Then we get this result. D0 is 1, and because here constant on the right hand side, D0 -1, and 0 on the right hand side. So D0 -1 equals to 0. So we get this result. And the first order, in this case, D1, coefficient of the first order power. But on the right hand side, there is no term. So coefficient 0. So D1 is 0 here. By comparing the coefficient both sides, then we get this identity, and we can fix the di by sequence by continuing this similarly sequentially. Then we can compute every di here. So eventually 1 over g squared times hyperbolic sine g is equal to 1 over g cubed negative 1 over g times g plus 7 over 360 times g, and like this. Okay, the final problem is 7, but we have already checked it in the first time. This problem is to use mathematical induction to establish Leibniz's rule in section 73. So that's it for the exercise of 73.